All right, let's dive right in. Today, we're going to pull back the curtain and take a look under the hood of what is, without a doubt, the most complex thing humans have ever built. We're going on a trip, and we're going to follow one single piece of your data on its absolutely epic journey across the entire world. I mean, have you ever really thought about it? You click a single button, and in the blink of an eye, a message or a photo just materializes on a screen halfway around the planet. It feels like pure magic, but it's not. It's actually an unbelievably fast and incredibly organized trip. And, every great journey needs a map. Well, this is ours. We're going to use this to trace the exact path our little data packet takes, all the way from your screen to literally anywhere else on Earth. Think of it as our guide to the hidden superhighways of the internet. Okay, so every journey has to start somewhere, right? Usually it's that first step out the front door. Well, for our data packet, that front door is its local network. So, looking at our map, the journey begins right here, in this section on network types. You can think of these as the first few streets our packet needs to navigate before it can merge onto the really big interstates. Let's start with the two big ones. The packet's journey begins right where you are, probably, on a LAN, a local area network. This is your home's driveway. It connects your computer, your phone, your smart TV, all that stuff. But you can't get very far just rolling around in the driveway. To actually go somewhere, it's got to merge onto the WAN, the Wide Area Network. Now that's the interstate highway system of the internet, the thing that connects whole cities and even countries. Of course, there are other routes too. There's a MAN, or a Metropolitan Area Network, which is kind of like a city's main roads connecting big businesses or university campus. And then you've got wireless networks, which are basically the invisible roads, the radio waves, that let our data just fly through the air with no cables at all. So our packet is officially on the highway. That's great, but how does it know which exit to take? I mean, the internet is just a mind-boggling maze of billions of possible paths. It's going to need a guide. And the answer to that is right here on our map, switching and routing. This is the secret sauce. This is the system that gives our packet turn-by-turn directions at every single digital intersection it hits. This brings us to routing, and honestly, the best way to think about this is that it's the internet's own built-in GPS. It is a crazy fast, complex process that is constantly calculating the single best next hop for our packet to get to its destination. And it all boils down to this lightning-fast three-step dance. First, a packet arrives at a router. Second, the router just glances at the destination address, kind of like a mail sorter checking a zip code. And third, it forwards that packet along to the next router in the chain. This simple little dance happens over and over and over again. Your packet is getting passed between dozens of routers, crossing entire continents in less time than it takes you to blink. It's absolutely wild. Now, you might be thinking, how does all this not just descend into complete and utter chaos? I mean, you've got all these different devices from different companies all over the world. Well, it all works because everyone, and I mean everyone, has agreed to follow the same set of rules. And these rules make up what we call a layered network architecture. You can just think of them as the fundamental traffic laws of the internet. They make sure that data from any device, anywhere, can travel smoothly and be understood by any other device. The core idea here is layered architecture, and the Postal Service is a perfect analogy. When you send a letter, you don't just hand someone a piece of paper, right? No, you put it in an envelope. That's one layer. You write an address on it. That's another layer. Add a zip code, put on a stamp. Each step is a new layer of instruction. The internet does the exact same thing with your data, wrapping it in all these different layers of digital instructions. Now, while there are a lot of rules, there are two main rule books we should know about. First is the TCP/IP model. This is the practical, day-to-day language of the internet. It's the one that's actually being used out there on the digital highways. Then there's the OSI model, which is more like a conceptual blueprint. It's a universal guide that helps engineers design and troubleshoot the whole system. Okay, so let's recap. We have the roads, we have the GPS, and we have the traffic laws that everyone follows. But who makes sure the roads stay paved? Who makes sure the signs are clear? And that we don't end up in a massive digital traffic jam? Well, that brings us to our final stop on the map, network management. This is the crucial and often totally invisible work that keeps this entire global system up and running 24/7. These are the network administrators and all the automated systems. They are the literal road crew of the internet. They're the ones monitoring all the traffic, fixing digital potholes and managing the whole system to make sure our packets have a smooth, fast, and secure journey. And when you put it all together, the local networks, the global routing, these universal rules, and the constant management, you really start to appreciate a quote like this one from Eric Schmidt. It really is a staggering, almost unbelievable achievement of human engineering. So the next time you click send, just take a second to appreciate the incredible, invisible journey that little piece of data is about to take. Billions of these journeys happen every single second on a system that is constantly growing, constantly evolving. And that really just leaves one big question. What happens when the map itself needs to change? Well, that's the challenge for the next generation of builders. Thanks for joining me on this journey.